In today's digital landscape, simply having mountains of data just isn't enough to guarantee success anymore. I mean, it is incredibly easy to completely drown in all those numbers, or honestly, even worse, to start finding patterns that just aren't really there. The real challenge, the true art form here, is extracting valid, actionable truth without falling into some pretty disastrous analytical traps. So that brings us to a massive core question. How exactly do you derive truth from a towering pile of data? Well, answering this requires a whole lot more than just firing up a spreadsheet or running a quick script and hoping for the best. It requires you to become a highly methodical, highly credible truth seeker. And the stakes, they are absolutely immense, because major business decisions are going to hinge entirely on the validity of your findings. Think about a traditional academic psychology experiment for a second. Often, the dataset is small enough that a researcher can literally look at every single data point with their own two eyes. But modern high-dimensional data, like Google-scale logs, is enormous. It's messy, it's packed with dozens of attributes per row, and it features really complex temporal sequences of user events. You just cannot review every data point manually. We are operating in a totally different universe of complexity here. To navigate this, here's our roadmap for this explainer. We'll look at the search for truth, technical data examination, building a bulletproof process, the analyst mindset, and finally, embracing your ignorance. Let's jump right in. Starting off with part 1, the search for truth, navigating Google-scale data. You see, the best data professionals don't just calculate numbers. They build a solid reputation for making careful, credible pronouncements. There's a great quote that says, "Deriving truth and insight from a pile of data is a powerful but error-prone job." And it's so true. Making errors is easy. Finding the actual truth is hard. This isn't just about mindlessly crunching numbers. It's really high-stakes work. And the very first step toward building your credibility is fully acknowledging the inherent, sometimes terrifying risks of data analysis. Next up, part 2, technical data examination. Time to roll up our sleeves and wrestle with the raw numbers. Okay, there's this massive myth out there that with enough data, the noise just sort of magically goes away. It absolutely doesn't. You always have to consider noise, p-values, and confidence intervals. And you can't just stop at simple summary metrics like means and medians. You really need to look at rich distributions, like histograms, to spot weird multimodal behavior. Crucially, you've got to look closely at individual data examples to ensure your code is actually interpreting the data correctly. Plus, you need to be slicing your data by subgroups, like browser, locale, or device, to confirm internal consistency. And speaking of consistency, let's talk about outliers. They are literally the canaries in the coal mine. It is incredibly tempting to just, delete a weird outlier and move on with your day. But you must investigate them first. For instance, queries with unusually low clicks might reveal that your system is just failing to count clicks on certain elements. Don't casually exclude them. They might be screaming at you about fundamental problems with your underlying analysis code. Now, when you're slicing that data, you have to watch out for something called mix shift. This happens when the amount of data in the slices for each group is different, and it can lead to some major confusion, like Simpson's paradox. Think of a hospital appearing to have worse survival rates simply because it takes in much sicker patients to begin with. If you don't account for group sizes, a trend that appears in several different subgroups can magically disappear or even reverse completely when those groups are combined. It can entirely invalidate your comparison. But here is a critical reality check for you. With huge volumes of data, almost everything can look statistically significant. So you have to constantly challenge yourself, okay, even if it's true that value X is 0.1% more than value Y, does it actually matter? You have to balance statistical significance with practical significance. Basically, don't get lost in the microscopic details if the real-world impact is virtually zero. Moving on to part 3, a bulletproof analysis process. This is all about setting up a defensive perimeter around your insights so they can actually withstand tough scrutiny. The secret sauce here is this 3-stage framework: validation, description, and evaluation. First up, validate. Is the data self-consistent, and was it collected correctly? Second, describe. What is the purely objective interpretation here? For example, users make fewer queries. And third, evaluate. Is this actually a good thing for the user or the business? By strictly separating your objective description from your subjective evaluation, you prevent yourself from subconsciously bending the data to show only the results you desperately want to see. Now, when you launch a brand new feature, there's this massive temptation to dive straight into shiny, new custom metrics. Resist that urge. You absolutely must look at standard metrics first. Standard metrics are well validated, they're likely correct. If your new custom metrics don't make logical sense when paired with the standard metrics, well, your custom metrics are almost certainly wrong. Building a bulletproof process is basically detective work. You want to ensure your underlying models are rock solid and reproducible. So, how do we do that? Measure the same phenomenon in multiple ways. Check your new numbers for consistency against past measurements. If your new population average is wildly off from historical norms, you've got to investigate. Slice your data by units of time to spot breakages as systems evolve. And a pro tip: always apply your newly invented metrics to old, known features first, just to ensure they behave exactly as you'd expect. Part 4. The Analyst Mindset. Great analysis doesn't start by just aimlessly throwing machine learning algorithms at a giant wall of data. It starts with a very specific psychology. To do this job well, you almost need a mental duality. You have to be both the champion and the skeptic. The champion looks at a finding and asks, okay, what other data can I gather to show how awesome this is? But at the exact same time, you must be the skeptic, asking, what could I find that would completely invalidate this? This is an absolute survival skill, especially when a major stakeholder is breathing down your neck, desperately hoping you'll prove their pet project is a massive success. And we can't talk about being a skeptic without addressing the golden rule of data. Correlation does not equal causation. Just because event A and event B happen at the same time doesn't mean A caused B. You have to be aware of hidden effects that might be causing both. Or, the classic trap of multiple hypothesis testing, where, given enough dimensions, pure random noise will eventually look like a perfect alignment. You must critically validate causal theories before ever presenting them as established facts. This is exactly why you must share your findings with your peers first and external consumers second. Consumers usually have an agenda, right? They want the data to validate their previous decisions. But a skilled peer does not. A solid peer review will catch the gotchas, the weird oddities, and those multiple hypothesis testing errors way before you expose your data to the wider world. Which brings us to our final section, Part 5, Embracing Your Ignorance. I know it sounds counterintuitive, but acknowledging the limits of our certainty is the ultimate hallmark of a true professional. Nate Silver puts this perfectly in his book, The Signal and the Noise. He says, expect and accept ignorance and mistakes. Admitting the limits of our certainty helps make advances. Look, it feels terrible in the moment to admit you don't know something or to proactively own up to a mistake in your calculations, but doing so earns you immense respect from your team. And that respect, it directly translates into long-term credibility and impact. The reality is, much of the really hard, methodical work we've talked about today, validating datasets, checking population makeshifts, slicing by browser, it's totally invisible to the end consumers of your analysis. They just see the final, pretty chart. Therefore, your role transcends just number crunching. You are a storyteller. Your job is to gradually bring that invisible rigor to light, teaching consumers exactly why these methodical steps safeguard the entire business. Which leaves us with one final big question to ponder. Armed with these tools and this new mindset, how will you challenge your own data biases in your very next project? Are you going to be the champion or the skeptic? Keep questioning, keep slicing, and thanks for joining us for this explainer.